Okay, so picking up part 2 of homework 3-1, we'll get through hopefully questions 9 through 12 here. So the figure shows two forces, each of magnitude 4.6. The angle between the forces is 40, and they make equal angles above and below the horizontal. So that's actually very helpful for a lot of reasons. So I know the entire angle between them is 40, which means each of these, because they told me that's equal, is 20 and 20. It's also very helpful because I know that they have the exact same magnitude. They're both 4.6. So the reason that's so helpful is I can take each one of those forces, right, and as I break it up into the components, so here's force 1 going off this way and then up to the top, and then force 2, which does basically the same thing, right, except it's going down, so it's going over and then down, right? Well, the reason that's so helpful is I know that the two vertical components are going to be equal and opposite. Since it has the same magnitude and the same angle, those two vertical pieces are going to be equal and opposite, whereas the two horizontal pieces are going to be the same in magnitude and direction. So then really all I have to do is to find out which third force will balance out. Equilibrium, right, means the net force and the net acceleration equals 0. So then all I have to do is figure out what either one of these forces is and then double it so that that third force in the opposite direction would balance out each of these two. Right? So again, my goal is simply to find the cosine component of one of those or both of those and then add that up. Right? So 4.6 times, again, if this is my angle of 20, I'm just going to do 4.6 times cosine of 20, right? And then I'm going to double that. I'm going to end up doubling that to figure out what my total force needs to be, right? Because I have two of those components. So then times 2, and I'll just go ahead and do that all at once here. And so when I calculate the total, that ends up being about 8.645 newtons. And again, that would be going to the left. So then what third force? Well, the third force would have to be 8.645 newtons going off along the positive x-axis. Okay, so along the positive x-axis would be my third force. But anyway, hopefully this one wasn't too bad. Now obviously you could always break this up into components, and hopefully you would just see that those two vertical pieces cancel out anyway. But anyway, not a terrible question to get. So question 10 here is very similar to one of the questions we saw earlier. You could use a specific data point, but actually to get a better answer we would typically use the slope, right? And so if I look at the slope of this, my slope would be a over f, right? Well, in this case, a over f, if I'm thinking about that, right, ends up being, if I've got my force equals mass times acceleration, if I solve for a over f, so if I divide both sides by f, I get 1 equals m times a over f. And so then if I solve for a over f, I actually get 1 over m equals a over f. So my slope here, my change in this, would equal my change in 1 over the mass. So I could definitely use that slope to help me out. But again, in this case, I actually don't even necessarily need to mess with the entire slope. I can just choose a specific point. And so any point on here would work. You can use just about anything you want. At this particular location, I know that the force is 0.50. I know that the acceleration is 4.0. So if I use force equals mass times acceleration, and then just solve from there. So 0.5 equals mass times 4. So then my mass ends up being 0.125 kilograms. They do ask me, however, for the mass in terms of grams, and so I would just multiply that then by 1,000, and I get 125 grams. So I end up with 125 grams. Again, not a terrible question here, so don't make it worse than it has to be. So then question 11 here, right, gives me a graph of the x component of the acceleration, so that's all I'm seeing. And then they ask me at what time or times does the x component of the net force on the object reach its maximum magnitude. And notice they do include the magnitude, so I'm not worried about positive or negative. And so that's maybe the only real tricky part about this first part here. Because I just want the maximum magnitude, this positive 15 up here is actually smaller than the negative 20 that we reached down here. Right, so my maximum force would occur when I take my mass, which they gave me, times that maximum acceleration of negative 20, which again, I'm not worried about the sign, so I'm just going to call that 20. So my maximum force would be 2.4 times 20, right? And so you just calculate that, you get 48 newtons. Now it would be 48 newtons in the negative direction, but I don't care because it's just the magnitude, right? And then they ask me what time does that occur at. Well, this is 3, and do make sure you're paying attention to the units. Okay, so this happens at time equals 3 milliseconds. Okay, so if you just want to write it like 3 milliseconds, that's fine. Or if you want to write that as 3 times 10 to the negative third, that's fine as well. But anyway, like I said, hopefully part A wasn't too bad once you've kind of interpreted this graph and that question. Part B, what is the x component of the net force at t equals 0 and at 4.0? Okay, so really for part B, again, nothing too crazy here. The x component of the net force, which is what this graph is showing me, so at a time of t equals 0, well, I just look at my acceleration at that point. My mass is again still 2.4. My acceleration at that point is a positive 5. And because they did ask me for what is the actual component and not just the magnitude, I will go ahead and leave that positive in there. So my f at 0 seconds, my f sub 0 if you will, is 2.5 or 2.4 times 5, so that ends up being a positive 12 newtons. And again, the positive just telling me it's going in the positive direction. And then for the time of 4 seconds, again, do the same thing here. Right, we know our acceleration is negative 10, so my force at 10 seconds would be 2.4 times negative 10. I am going to go ahead and leave the negative in there because that will tell me the direction, right? So I know that would be negative 24 newtons. Again, the direction just indicating that that force is directed in the negative direction. So anyway, hopefully question 11 wasn't too bad to set up. So then for the last question here, and I'll go ahead and write down the correct answer for those of you that want to make this quick. So 1.06 meters per second squared. If you got that magnitude correct, good for you. Feel free to skip the rest of this video. For those of us that need to see this worked out or just want to see this worked out, right, I've set up the diagram. So first and foremost, make sure you agree with my diagram, right? So they told me this force was clockwise from the positive x-axis, so down here. And then the second force there was clockwise from the positive y-axis, so it's actually up here. But then if I want to find the magnitude of the object's acceleration, well, in order to find the acceleration, I really want to find the net force first, right? So my goal is I need to find the net force. Well, in order to do that, I simply need to break both of these up into its components. So I'm going to break this force that's going up into how much does that go up, how much does that go over. So I'm going to call this Fy sub 1 and then Fx sub 1. In this case, Fx sub 1 would equal the sine component since it's the opposite side. So my Fx, and actually they maybe tell me that's the second force, but it doesn't really matter. So my Fx sub 1 here would be 35 times sine of 32, which ends up being about 18.5. My Fy sub 1 would be 35 times cosine of 32. Again, just finding this leg of the triangle. And that ends up being about 29.7, rounding that off a little bit. And then I'm going to do the same thing right for my second force here, and I can do it whichever way I want in terms of I could go over and down or down and over. I will do this so that way I can use this angle of 59 degrees. If I did go down and over, I would want to find the complement of that first, right? But when I set it up this way, then the F sub x and the F sub y actually reverses the components. And what I mean by that is my Fx of 2 is actually going to be 65 times cosine of 59, right? Which ends up being about 33.5. And then my Fy sub 2 ends up being 65 times sine of 59, which ends up being a little bit greater at about 55.7. Now the last thing that I want to do is just think about all of these components and whether they should be positive or negative. So because this one went up and this one went to the right, I'm going to go ahead and leave both of those as positive quantities. The x component for my second force down here still went to the right. However, it did go down, so I'm going to define that 55 as a negative 55. So then really all I have to do is find my resultants, right? I need to find my total x and my total y. So finding the sum of my x components, finding the total sum of my x components, is a positive 18.5 plus a positive 33.5. So that ends up being a positive 52 newtons, which tells me that resultant goes off to the right, 52. And then finding the sum of my vertical forces, right? I've got a positive 29.7. I have a negative 55.7. So that actually ends up being a negative 26, which tells me that the resultant between those two vertical components actually ends up going down. So then my triangle here, right, my final triangle for the net force would be over 52 and down 26, and then I would find the hypotenuse of that to find my net force. So I'm going to go ahead and do that, just doing the Pythagorean theorem, right? So setting up the Pythagorean theorem, solving for my net force, the magnitude of my net force ends up being 58.1. And notice I'm not worried about the direction because this one didn't ask me, it just asked me for the magnitude of the acceleration. So I don't care about the direction. So the magnitude of the net force is 58.1. Once I know the net force, it simply is a matter of force equals mass times acceleration, right? So now that I know my net force is 58.1, and they gave me in the problem that the mass is 55, I can pretty easily find my acceleration by just dividing 58.1 by 55, and that's where I got my 1.06 meters per second squared. So again, making sure you're pretty comfortable with a problem like this, breaking up your components, finding your net force, and then using your net force to find the object's net acceleration. Right? So nothing too crazy here, but make sure you are comfortable with that process.